Today we are going to see dynamic programming for sequence alignment. When you see dynamic programming, it's of two types. The first one is global sequence alignment using Needleman-Wunsch algorithm, and the second one is local sequence alignment using Smith-Waterman algorithm. And here in dynamic programming, that is to this global programming, we are going to see today. The entire program will be done in three different stages. The first one is the initialization matrix construction, second one is the path matrix construction, and the third one is tracing back. So these are the three different stages through which we are going to align the sequences. And in any program, the entire stage, whenever we are going to fill the sequence, suppose you are going to fill the value for this cell. The value will be derived from three different directions. One is vertical, the second one is diagonal, and the third one may be the horizontal direction. It is I minus one direction, or j minus one direction, or the diagonal that stands for I minus 1 comma j minus 1 direction. This is the diagonal direction. And here, this is the formula for calculating the values for each and every cell. F of I comma j is equal to maximum of any one of this direction. This first one stands for the diagonal, and this is for the horizontal, and this is for the vertical. These are the three different directions. Let us see how we are going to fill the initialization matrix. Initialization matrix, and in which we have to write down the first sequence like this, and the second sequence must be written like this, and we have to fill the cells with the value. That value will be from this Blossom 50 matrix. This is a standard matrix. Whenever we are using this Blossom 50 standard matrix, the gap value will be always 8. When we use Blossom 50, the value of gap penalty value will be 8. So this 8 is filled in all the gaps, and there is a border cells. And here also, right from the top till the bottommost cell, we have to fill the gap penalty value. And in each and every cell, we have to get the respective value from the Blossom 50 matrix. And this is the typical initialization matrix, and this is the way we have to fill. Once when this is ready, we have to go for the next stage, that is the path matrix construction. And this is the typical path matrix construction stage, and here this is the starting point. I0, J0 value of this cell, this is cell, the value is always 0. Once when you start from this, since it is global sequence alignment, it will begin with this corner sequence or the cell. And here, when we see this boundary layer, since the gap penalty value is 8, if we move up, that is a vertical move, there is no value, so we can't get anything from this side. And this side, that is the diagonal side, here also it is impossible because nothing is available here. So we cannot get any value from this side. And the only possibility is the vertical move. So here already 0 is there, 0, minus 8, that is the gap value, we are getting minus 8. And come to this cell, again the only possibility is horizontal move. Here the value is already minus 8, and the gap value minus 8, we are getting minus 16 like this, minus 24, 32, like this it goes. And this side, when we fill the boundary value for this, that is top to bottom of the leftmost column, again the I0, J0 value is 0, and here the only possibility is from vertical move. And here the diagonal is impossible since there is no value here. and this side also, that is horizontal also, no value. So only possibilities are vertical, and here 0, minus 8, we are getting minus 8, and this one already minus 8, and minus 8, minus 16, and like this in all this boundary cells we are getting only minus values, whether it is the topmost one or the leftmost value. Boundary values are always minus, that is a negative value. And when we come to this, here all the three directions we can get the value. When we move up, minus 8, it is minus 16, and this end again minus 8, minus 16, and this side, that is a diagonal move. When we get the value, that is 0, minus 2, that is the initialization value of the same cell, minus 2. So we are getting minus 16, and minus 2. Among this, minus 2 is the maximum, so we are entering minus 2 here. And come to this, when we move up, minus 16, minus 8, minus 24. And this side, when we move minus 2, minus 8, it is minus 10. When we move diagonally, minus 8, and the initialization matrix value of this cell, that is minus 1, so you are getting minus 9, so we are entering this value. So like this, we have to fill all these cell values. This, we have filled all the cells. Now the second stage is over, that is the arithmetic construction is over. We are entering into the last stage, that is the tracing back. As I said earlier, the tracing back will start from this corner and it will end up with this corner, right? And here, once when you see, we have to carefully see the arrow is moving up or horizontally or diagonally. So based on the move, we have to enter into the next cell. See here, from this corner, since the arrow is moving diagonally, if it is moving diagonally, it indicates there is a match. If it is moving up, that is vertical move, it indicates there is a gap in the upper string. And if the movement is horizontal, it indicates there is a gap in the second string, that is the lower string. So let us start this alignment program. So here, when we start from this corner, see the move is diagonal. So here, the E from the first string with the E from the second string, that is E aligned with E, there is a match. Once when we enter in this, it is moving up, so it indicates there is naturally a gap in the first string and the A is aligned here. From this point, again it is further moving into diagonally into the next cell. So it indicates there is one more E that is aligned with the second string E. E with E. Now, once again, the move is diagonally, and here the H is aligned with H. Once again, it is moving horizontally. Since the move is horizontal, it indicates there is a gap in the second string. So naturally, the G from the first string will occupy this place. And once again, when you see the move is diagonal, so W from the first is aligned with the second string W. It is a match, and once again the match is there. That is, since the move is diagonal, A is aligned with another A, and further also it is moving in the diagonal way. So first string G is there, and since that move is diagonal, there is naturally a gap in the second string. Once when you see, now again it is moving diagonally, so here A from the first is aligned with the P from the second string. Now another two movement is diagonal only, so you put two more gaps in the second string, and E from the first and the A from the, H from the first string is aligned with this. So now this is the typical alignment program. So now we have completely aligned the given string 1 with 2, and this is the total global sequence alignment. Thank you.